Hey, what's up, class of 2021? All right, we're going to work with volume a little bit more this week. Volume of a cone here. So we worked with volume of a cylinder last week, and volume of a cone is working kind of in the same way. The volume V of a cone is 1/3 the product of the base times the height, the area of the base times the height. And you'll remember the volume of a cylinder from last week was just the product of the base and height. So, and we'll look at that video, a little model of why that is. Why is a cone 1/3 of the volume of a regular cylinder, okay? So here's the algebra. Volume is equal to 1/3 base times the height. The variable is a big B because there's a formula for the base. It's the area of the circle, which is the base is pi r squared. Pi, and we use 3.14 for pi times the radius squared. Okay, cool. So here it is. So we're going to go ahead and work with this formula. Here is a cone shape, like ice cream cone, and it has a height of 6 meters, and a base. What we know about the base is the radius. So from the center point of the base circle to the outside circumference is 2 meters. So we've got our formula. Volume is equal to 1/3 base times height. So now we're going to do 1/3 times pi times 2 squared, right? Because it's radius squared. So I'm just going to write that as 4. And then times 6. Okay? So I'm going to go ahead and multiply my 1/3 and my 1/6. This is all multiplication. That's commutative property. So I could say 2. 1/3 of 6 is 2. And now I've got the 3.14 times 4. Why don't I use a calculator? Okay, so 3.14 times 4 equals 12.56. There it is. And so then the volume, then we would say, is 2 times 12 is 24, and then 56 is another 0.12, so 25.12. And then the unit is what? Meters. And so meters, is it just straight meters? No, that's a line. Is it meters squared? No, that's a flat surface. We're meters cubed because it's a volume, it's cubic, like a cube, like three-dimensional. Okay, final answer. Cool. So this is this topic is about just being able to conceptualize it and then use a formula. So there we go. All right, so now working with this situation, we'll go ahead, we're going to look at two others. Here you can see they give us the height and they give us the diameter. What's the relationship of a radius to a diameter? Okay, so volume is equal to 1/3 base times height. There's our formula. And so let's go ahead and do that. So we got volume is equal to 1/3 the base. Now I don't want the diameter, I want the radius. And so that's half the diameter. So that's 2 times 2 squared. It's actually going to be 4 times pi, or pi r squared. Again, you can do it in any order. And then times 4. Okay. So then we could say, I'm going to do all of this first. So that's the 4 times 3.14. I just did that. And clear 4 times 3.14. 4 times 3.14 is equal to that 1256. Okay, so volume is equal to 1/3. And then pi r squared was 12.56. And then times 4. Okay, so now I'm just going to multiply all this together. So 12.56 times 4 is equal to 50. Go ahead and write it out. So I got 1/3 times 50 and 24 hundredths. There it is. All right. And then this is saying multiplied by 1/3, which is the same thing as dividing by 3. So the volume, and we will, you can approximate at the 10th or the 100th. So the volume of this cylinder, the amount of space inside of that cylinder is 16, and I'll do it to the hundredths, 74 hundredths inches cubed. All right. So there we go. That's that volume. So for the other example problem I want to do with you all, in this case, we know the radius, great, because we need to know the area of the base, which is pi r squared. And what we don't know is a height, question mark, but we do know the total volume. So mathematics is about being flexible with what you know, staying engaged with it, all of that, all right? So what I know is that the volume is 956. It's the volume. And volume is equal to 1/3 the base, which I don't know, so I'm going to write in base. I haven't figured it out yet, times height. Okay, so there it is. That's a great first step for us. I knew the volume. I put that in here. Next step. So again, 956 is equal to, now the radius was 9 feet. So it's going to be 1/3 9 squared. I'll write pi first because that's the way it's usually presented. Pi, and then radius squared. Radius is 9, so that's going to be 81. 9 squared is 81. And then times the height, which we still do not know. Okay, so now I'm going to work with this. We have pi, and the value we use for pi is 3.14 times 81 equals 254.34. So 956 is equal to 1/3 254.34 times the height, which we do not know. Multiplying by 1/3 is like dividing by 3. So 254.34 divided by 3 is equal to 84.78. Let's keep going. 956 is equal to 84 and 78 hundredths times height. And so now what's our last step? You should be thinking, okay, I want to know what height is. I don't know what it is. So I'm going to solve for the variable that is height. So to do that, I need to divide both sides by this 84.78. I need to divide both sides by 84.78. All right? Okay, so let's find out what happens when we do that. I got 956 divided by 84.78 equals, cool. It's 11 and 0.27. That's what we're going to go. Okay, so so height, that's what it is. Height is going to be equal to, I'll put it up there, approximately, which is like the little squiggle sign, 11 and 0.27 feet. And in this case, you should be thinking, oh, wait, I'm always using cubic feet, right? Because we're finding volume. True, if you're finding volume, but here really the missing thing was the height. And so height is just straight units. It's just feet. Got it? All right, class of 2021. Keep going. You got this. Here are your practice problems. Three practice problems. I think you're up for it. Okay, and number 1, you know the radius and the height. And number 2, you know the height and the diameter. And number 3, the cone fell on its side. Really doesn't matter. You're finding the volume and you know the height and you know the radius. Okay? Go do it. There they are. So you pause, copy them down, and rock out.